Welcome to Dijkstra's algorithm. So as with all things in D1, we need to start with an aim and an actual algorithm. And the point of Dijkstra is to try and find the shortest path from one vertex to another, from A to B. I'm not going to read through this because it's going to be on the next slide, but this is essentially what we're working with. And here is an actual example of its use. So we're going to do this as a sort of walk and talk example. There will be a few bits that maybe don't make sense first time round, but you just have to keep applying it. So, step 1, label the start node 0 and box this label. So, when we say label, we're going to put label in the top right according to this little key. And that key might change from question to question, so you might have ones where it says it needs to have the vertex on there as well. But there, we labeled it 0. Box this label. Now, boxing means, as I put on this little side notice here, transferring the best value in the temporary label to the label part. So our temporary labels are here and there's none of them there. And noting down the order that it was boxed in. So this is the first thing that we have quote unquote boxed. So we put down its order is 1. This is part of the evidence of the question, and they'll be looking through and seeing have you boxed your things in the right order. So we've done step 1. Step 2. Consider each unboxed node joined to the last box. So we just boxed A. We're going to consider B, D, and C as they are all connected to that boxed node. Now, it says if the label plus the arc is less than the temporary label there, we can update our temporary label. Now, temporary labels are values that go in this sort of large area below at the bottom of this label. And it says label plus arc. So the label for A was 0. And we're going to add the arc that takes us to B or C or D. So to take us to B is a 15 arc. 0 plus 15 gives you 15. There's nothing written in the temporary labels already, so we're just going to write down 15 again. Okay, and we're going to do the same for D and C. So for D, 0 plus 19, and for C, 0 plus 10. So that's our step 2 there. We've updated our temporary labels. We've increased these values on the bottom. You can note I'm writing these on the left-hand side. That's because I'm going to write in more temporary labels as we go through the process. Now, step 3. Choose the smallest unboxed temporary label and box this. So we've got a choice between a label of 15, 19, and 10, and we want to pick the smallest one, which is C. So we're going to box this. Remember, boxing means transferring the best value in the temporary label to the label. So we're going to now write 10 as our permanent label. And the order it was boxed, it was the second thing that we boxed. Now, that is it as far as Dijkstra's algorithm goes. It's really good because you just repeat that step over and over again. So let's see. Go back to step 2 now. Consider each unboxed node joined to the last box. So we're going to consider D and F because they're the ones that are joined to C. And we're going to consider if label plus arc is less than the temporary label that's already there. So when we're considering D, we're taking the 10 from C and the 16 from the arc and saying, well, is 10 plus 16 less than 19? And it's not, so we won't write it in. If it was, we would write it in. So we're not updating the temporary label for D. For F, 10 plus 14 gives us 24. There's nothing there, so we're going to write that in. So that's our step 2 done again. And we'll consider step 3 again. So 3, smallest unboxed temporary label, that's B in this case, because D is 19 and F is 24. Label it, 15, box it, order 3. Now we go back to step 2 and we consider the arcs from B. So for E, that would be 15 plus 17 is 32. For D, that would be 15 plus 7 is 22. That's not bigger than 19, so we won't change it. Go to step 3 again. We're going to box off D this time, so 4 and 19. And we'll consider the arcs that come from D. So that's E, G, and F. So E is the first one where we're going to actually update a temporary label. 19 plus 12 gives you 31. So we're not going to cross through that 32. We still need to show evidence that we considered it once, but we're now going to upgrade that temporary label to 31. For G, that's going to be 22, 19 plus 3. And for F, 19 plus 6 is 25, so yeah, we can't quite update that. Step 3 again, we're going to box G this time, because 22 is the smallest number we got. And we're going to consider the arcs from G, so that means E, H, J, I, and F. All of those are unboxed, all of those are connected to G. So for E, 22 plus 20, no, that's not too small. For H, 22 plus 4, there's nothing written there. For J, 22 plus 11. So G, for I rather, 22 plus 1. And for F, 22 plus 9 is not smaller than 24. So we're going to box off I, 6, 23, and we're going to consider F and G and J. F isn't going to change, 23 plus 5 is not smaller than 24. J isn't going to change, 23 plus 18 is not less than 33. So we'll box off F next, 7, 24. Nothing is connected to that hasn't been boxed, so there's nothing to consider. H should be our next one, 8, 26, and consider E and J. 26 plus 13 is not less than 31, so E won't change, and 26 plus 2 is smaller than 33, so we'll update that to 28. And then we'll box off J next, 9 and 28, and at this stage we are actually done. It's because step 4 says to repeat step 2 and 3 until the destination is reached, which we've done. We've reached J. We wanted to go from A to J. So what is the shortest route from A to J, and give its length? So the length of the shortest route from A to J is 28. To find out what it is, we'll write A on one side, J at the other side, and we'll work backwards, which is what this step 5 is about. So where did that 28 come from? That 28 came from adding 2 to this 26, so we must have come from H. That 26 came from adding 4 to 22, so we must have come from G before that. That 22 came from 19 plus 3, so we must have come from D. And that 19 came from 19 plus 0, so came from A. So that is our shortest route. If we wanted to draw it out, we would have something that looks like this. Oh, wait. So AD, I've got to write this properly, ADG, H and J. And the lengths there were 19, 3, 4 and 2. So yeah, that is Dijkstra's algorithm. It's confusing to start, but it's very straightforward to go through once you've got the idea of that. Box a label, check the labels, box the label, check the labels. We're going to look at a couple more exam versions now. So this is what your exam question is going to look like. This is taken from an old decision paper. It gives you obviously some context, and it's important to read that because decision is one of those one of those papers where you lose marks for getting the wrong units, putting stuff in the wrong sort of rounding, that sort of thing. We've got a series of towns that surround a central city K, and we want to use Dijkstra's algorithm to find the shortest route from A to E. Now, you do not ever have to draw out all of the boxes. They will have an insert or something in the answer book that you can use. So we're going to use that. Here it is. This contains all the same information of the previous page. So we wanted to go from, let's just double check, we wanted to go from A to E. So we're going to start at A and we're going to label it 0 and order it 1. It's the first thing we chose, label was 0. Consider the temporary labels from A. 20, 36, 30. Box off B to 20. Consider C and K. So we'll update that to 35. And we will update K to 30 from 20 plus 10. Then we box off. So you've got two things which are worth 30 at this stage. Up to you which one you want to choose. I'm probably just going to do them alphabetical order. So I'll box off F next. 3 and 30. And then consider K, no change. Consider E, 60. Box off K next because that's also worth 30. 4 and 30. Consider C, not going to change. D is going to update to 45. D is going to change to 45, and E is also going to go up to 58. 30 plus 28. Then we box off C next. 5, 35. Consider D. D would be 43 from 35 plus 8. Then we box off D. Then we consider E, which will update again to 57. And that will go to 7 and 57, and we stop because we've got to our destination. So what was our minimum route? Was 57 kilometers. And the actual route itself went from A to E, so let's work backwards. We got that 57 from adding 14 to that 43, so we came from D. We got that 43 from adding 8 to that 35, so we came from C. We got that 35 from adding 15 to 20, and we got that 20 coming from A. So it would be A, B, C, D, E, which is a bit disappointing, but there you go. We're not going to do the part B here because I want to focus on the Dijkstras, but that's a typical follow-up question would be to use some Kruskal's or Prims or route inspection, which we haven't done yet. So one last thing that we can do is we can add on directions. We can add on arrows to our diagram, and that's just something you've got to factor into, can I actually travel to this point? So here's our Dijkstra's algorithm with our arrows added on. We want to find the shortest distance from A to H. Most of this is going to be exactly the same. We're going to box off A. We're going to update our temporary labels. We're going to box off B. We're going to update our temporary labels, so 219 there and 271 there. We're going to box off D next, so 3 and 125, and we're going to update our temporary labels, so this would go to 199, 125 plus 74, and this would go to 192. E is the next one we box off. And then this is an example of where the arrows are coming in. We can't update the F temporary label. 192 plus 75 would be less than 271, but we can't travel that way. So that's the only thing you've really got to bear in mind here. So we can just update this one to 270. Then we box off C. Nothing coming from there. Then we box off G. We could update the F label if we needed to, but that's not going to help. That's 372. And this is going to be 405. And then we'd box off F, and we could improve this to 389, and then we box off H. So the total distance from A to H is 389 meters at its shortest, and the actual path we took going from A to H, well, that 389 came from that 271, and that 271 came from this 124, and that came from here. So it'd be A, B, F, H. There you go. Dijkstra's algorithm. Lovely piece of work.